Hello again. I hope that you are doing well. Today's lesson should seem a little easier compared to some of the others that we've had. We've been spending a lot of time working with fractions, and fractions are really great because when you add them or subtract them, or multiply or divide for that matter, you end up with exact answers. We don't have to worry about any rounding error entering into our calculations or propagating through our calculations and becoming larger and larger. So fractions are really great for that. On the other hand, people like decimals. They're just nice. They're easy to add, they're easy to compare. So it's to our advantage to be able to convert between fractions and decimals, in particular from a fraction to a decimal. So that's what we're going to do today. Our job today is to write decimals as fractions in lowest terms and to go the other direction and write fractions as decimals. We're going to start by going all the way back to the place value chart that we saw at the very beginning of the class. All right, here we go. You'll remember that all of these values here represent the fractional place value names. And all of these fractional place value names end with the letters THS. And that's important, and that's why they're in red on this chart. Not like you need this in your notes or anything, but if you were to look at the fraction with 3 in the numerator and 5 in the denominator, we would say 3/5. And it would tell you that it takes 5 pieces to make a whole. We have 3 of those pieces, and each of those pieces is called a fifth. The same thing, of course, is true for all the place value names that are in a decimal. 1/10th, 1/100th, 1/1000th. You can feel the fraction as you say it. So every decimal has a whole number part and a fractional number part, and of course those are separated by a decimal point, which is right here to the right of the ones place. So there's our decimal point. The decimal point separates the whole number part from the fractional part. And of course there it is. When you read numbers, we've done this before, the word and. So we'll do that in capital letters just to sort of emphasize it. That tells us where the decimal point gets located. And of course you do this all the time whenever you write a check. You might want to write a check for $5.93. And when you get to the part of the check where you have to write this in words, you actually say 5 and 93 hundredths. And some of you even write this fraction at the end of your written words. Okay, so one of our big deals today is that every decimal can be written as an equivalent fraction. Let's start with this one here. The key to writing a decimal as an equivalent fraction is to read it out loud properly. So this decimal is 37 and 72, and then we need to find this place value right here under the 2. So we have tenths where the 0 is, hundredths where the 7 is, and thousandths, right, with that THS where the 2 is. So this is 37 and 72 thousandths. Whoops, that's backwards. Or not backwards, but the comma's in the wrong spot. There we go. 32 and 72 thousandths. Hang on. There, that's better. And that's a fabulous fraction, except for the fact that this should bother you a little bit because it's not in lowest terms. The cool thing about putting decimal numbers into fractions in lowest terms is that all of our place values are powers of 10. 1,000 is just 10 times 10 times 10. So if we're going to look for common factors, we care about the factors of 10, because those are the only things that could be common, which means all we're really looking for are 2's and 5's. So if we divided the numerator and the denominator by 2, we would have 37 and, well, let's see, 72 divided by 2 is 36. 1,000 divided by 2 is 500. Okay, that's better, but it's still not in lowest terms. Let's do this again. 36 divided by 2 is 18. So this is 37 with an 18 in the numerator. 500 divided by 2 is 250. Getting closer, but I can still divide both of those numbers by 2. So let's do this one more time. 18 divided by 2 is 9. 250 divided by 2 is 125. Now I know that 9 factors, but it's not worth my time to do it because 9 factors into 3's. In particular, it doesn't factor into anything that's got a 2 or a 5 in it. So this is it. We're done. Why don't we try another? Let's flip the page and recap a little bit of what we said a second ago. So place values are all powers of, yes, 10. And to write a decimal as a fraction in lowest terms, we need to look for common factors, but we only need those things that are factors of 10, because otherwise they wouldn't be common. So we care about 2's and 5's. 2's and 5's are really nice because you can see right away without doing any calculation at all whether or not they are going to even be a factor of a number. A number is divisible by 2 if it is even. And of course that means you check to see whether or not the number ends with a 0, a 2, a 4, a 6, or an 8. A number is divisible by 5 if it ends with a 0 or a 5. So all we have to do is look at the number to see if it's got a 2 or a 5 as a factor. We'll know instantly whether or not the fraction can be written in lower terms than what it already is. So let's try this one more time. 0.0075. Just like before, the first thing to do is to read this number properly, which means we have to figure out what this far right decimal place is. So we have tenths, hundredths, the 7 is in the thousandths place, and the 5 is in the 10,000ths place. And this place value name is hyphenated so that you know it's not 10 1,000ths. Anyhow, 75 10,000ths. All right, let's look for some common factors. We can see right away that both 75 and 10,000 are divisible by 5. So we're just going to divide both of those numbers by 5. And that will give us, let's see, 75 divided by 5 is 15. 10,000 divided by 5 is 2,000. Oh, we've got another common factor of 5 in there, so let's do this one more time. We'll divide the numerator by 5. We'll divide the denominator by 5. 15 divided by 5 is 3. 2,000 divided by 5 is 400. And we already know that there aren't any factors of 3 in 400 because this came from 10,000, and 10,000 is made up of 5's times 2's. So that's it. We're all done. The end. Now, of course, your calculator can do this. You have a fraction to decimal converter key. That's what these two little arrows mean. Sitting on your calculator. It's right over here, just a little bit down and to the left of the set of arrows. Let's see what happens. So let's see, we have 0.0075. And we would like to turn that into a decimal. So we'll use second to access the function on the calculator. Use the converter key. And there we go, 3/400ths. Pretty slick, huh? Which is great. But remember, calculators have trouble with display space, especially when it comes to working with fractions. There are a lot of times when you are actually smarter and faster than a calculator. Let's try the next one. All right, we have a very small number of volts. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. This is 4 is in the 10 millionths place. Right there. So we need 4 over 10 million. I know. Let's see. Can the calculator do this? 0. How many zeros are we going to need? 1, 2, 3, 4, 5, 6 zeros and then a 4. 1, 2, 3, 4, 5, 6 zeros and then a 4. And let's turn this into a fraction. And the calculator says, I ain't doing it. Don't wanna, don't have to, I ain't doing it. All right. But this really isn't so bad. We already know that both of these numbers are divisible by 2. 4 divided by 2 is 2. 10 millions divided by 2 is 5 million. And we see pretty quickly that we can do this again. So if we divide the numerator by 2 and divide the denominator by 2, maybe you saw right at the beginning that you could divide them both by 4. That would have been faster, but this isn't wrong. 2 divided by 2 is 1. 5 million divided by 2, let's see, we'll focus here on the 50. 50 divided by 2 is 25, and then keep all the rest of the zeros. 2,500,000. There we go. There's the fraction the calculator didn't want to show you. And really, it wasn't all that hard. Okay, so let's go the other direction. Let's write a fraction as a decimal. Well, you know, let's see. We already talked about why we would want to do this. Because if we're being careful and conscientious about our calculations, we're working with fractions to begin with, but then we're going to pass our results on to people who may prefer to have them in decimals. If your fraction has a place value denominator, well, you know, that's just super easy and very nice, and there's really nothing to do here except read it. 5 and 83 hundred-thousandths. We just translate this. 5, that's our whole number, and there's the decimal point. And then we have 83 hundred-thousandths. So we need to find that hundred-thousandths place. Tenths, hundredths, thousandths, 10,000ths, 100,000ths. The last digit belongs in the last spot you made. So the 8 is there and the 3 is the last one. So this is our 100,000ths place, and the last digit goes here. We did this a long time ago, so it's probably not a bad idea to do it again. And of course we fill in the remaining places with some zeros as placeholders. But that's really all there is to it. So the next question really is, what happens if my fraction doesn't have a place value denominator? Because we've been doing a lot of work with fractions, and quite frankly, we didn't see very many denominators of 10 or 100 or 1,000. We saw lots of 8s and 32s and 14s and things like that. So let's flip the page and see what we might actually do. Every fraction has a fraction bar. And the fraction bar tells us that we need to divide. It's always numerator divided by denominator. Right, we read a fraction straight down. So if you had 5/8, we're asking how many times does 8 go into 5? And of course 8 goes into 5 less than 1 time, which makes sense because 5/8 is less than 1. The thing about dividing when we're talking about decimals is that you don't get to use any remainders. So we're going to do long division again and see what happens. Let's start off with 5/8. We already know that we'll set the long division problem up as 8 going into 5. Of course, 8 doesn't go into 5, so we need to add a decimal point and a 0 and ask ourselves, how many times does 8 go into 50? Bring that decimal point straight up. 8 goes into 50 6 times. 6 times 8 is 48, and subtract. We don't want a remainder of 2 here, so we're just going to add a 0 and bring it down and ask ourselves, how many times does 8 go into 20? 8 goes into 20 twice. 2 times 8 is 16, and subtract. Oh, drats. Can't have a remainder. Better add a 0 and bring it down. 8 goes into 40. Oh, good. 5 times. 5 times 8 is 40, and now we don't have a remainder, and we can stop. So 5/8 is worth 625 thousandths, right? Or 0.625, whichever way you like to say it. All right, your job. We're going to write 8 and 11/32 as a decimal. What we're not going to do is turn this into some improper fraction. When you read this, we say 8 and 11/32. So we already know the whole number portion is going to be 8. The and tells us where the decimal point goes. We just care about what 11/32 is worth as a decimal. Now this one's going to take a little bit of space. I know, just because I made the problem. So start it over here. We have 32 dividing into 11. Of course, 32 doesn't go into 11, so we'll add a decimal point. Bring that straight up. I like to put a 0 in front of it so I can keep track of it. And we say 32 goes into 110 how many times? Oh, let's see. 3 times 30 is 90. 4 times 30 is 120. I think I'm just going to stick with 3 times. 3 times 2 is 6. 3 times 3 is 9. We subtract. That gives us 14. Right, whatever this number is down here, of course, is not allowed to be any larger than what our divisor is. So this is good. Can't have a remainder, so we'll add a 0. Bring it down and ask ourselves, how many times does 32 go into 140? I'm going to try 4. 4 times 2 is 8. 4 times 3 is 12. Subtract. We have 12 left over. That's good. Okay, from here, pause the recording, finish this off on your own, and then come back. Okay, there's mine. Compare it to yours. See how it looks? I know, it took a little while, but we got there. It's rather long, but that's okay. We just keep on adding zeros and bringing it down and repeating the process. And it's really not so bad, it's just long. All right, so let's come down here and write our solution in the solution spot. 5/8 is equal to 0.625, and hopefully you already knew this answer before we actually got it, because 5/8 is one of those workplace fractions that should be fairly common to us. Even if you didn't know it, this should look familiar. 11/32 is also a workplace fraction, but a lot of people don't know their 30-seconds. At any rate, the whole number is 8. Don't lose the whole number. 8 and. After that, 11/32 is worth 0.34375. And that's pretty much all there is to it. Except we have one thing that we need to watch out for. Let's flip the page. Whoops, maybe not flip the page quite yet. Hang on a second. We forgot about the bottom. I forgot that we had some vocabulary coming here. If this long division process eventually ends, the result is what's called a terminating right? Just like Arnold Schwarzenegger in The Terminator, it means things are going to end. This is called a terminating decimal. It means that the fraction's decimal equivalent has a finite number of decimal places. It eventually ends. The division will stop and we can say exactly what the answer is. Okay, so the one problem that we may run into is that there's nothing that says the long division process has to end, ever. The nice thing about this is if you eventually see a group of digits that continually repeats, we can deal with it. We end up with what's called a repeating decimal. And the nice thing about fractions is those are the only options. You either get a terminating decimal or you get a repeating decimal. There is no fraction that has some crazy decimal portion that keeps on going on and on and on forever without some sort of pattern. It either stops or it has a portion that repeats. So let's fill that in. The decimal version of every fraction is either a terminating or a repeating decimal. Let's start with one that should be rather familiar to us. Give ourselves some space here. We would like to write 2/3 as a decimal. We already know how to set up the problem. We're asking ourselves how many times does 3 go into 2? We're expecting a decimal answer because 2/3 is less than 1. We know 3 doesn't go into 2 any times at all. So put in a decimal point. Make sure you bring it straight up. 3 goes into 20. Let's see, 3 times 6 is 18, so 6 times. We do the subtraction. There's 2. Add a 0. Bring the 0 down. 3 goes into 20, 6 times. 3 times 6 is 18. Subtract. There's a 2. Add a 0. Bring it down. And right about now, you are seeing that this can repeat on and on and on and on forever. We'll end up with a whole bunch of 6s here, dot, 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 to show that it goes and repeats. Now, it's not up here in the answer that we're looking for the repeating digits. What we're looking for is the repeating work. That's the part that we care about. We start seeing a pattern in the process. All right, so if we were going to say what decimal equivalent do we have for 2/3, we really couldn't give an exact answer in terms of writing down all of the digits because these 6s go on and on forever. What we do is use a repeating bar. So we have 0.6 and we put a bar over the 6. That's called the repeating bar, to tell people that the portion that the bar is over repeats forever and ever. Let's try this with 3/22. We want to ask ourselves how many times does 22 go into 3? 22 doesn't go into 3 any times. Bring that decimal point straight up. Add a 0. 22 goes into 30 once. 1 times 22 is 22. And subtract. And so there's an 8. Add a 0. Bring it down. How many times does 22 go into 80? Well, 20 times 4 is 80. So 22 times 4 is going to be more than that. Let's try 3. 3 times 22 is 66. Subtract. That's 14. Add a 0. Bring it down. Oh gosh, how many times does 22 go into 140? Well, 20 goes into 147 times, so let's try 6. 6 times 22. 6 times 2 is 12. Carry the letters, 132. Okay. Subtract. There's an 8. Add a 0. Bring it down. And now we can see that something is going to start repeating because we've got this 80 again. 22 goes into 80 3 times. There's that 14 remainder. And we're back now to a spot where we can see the repeating work over and over again. So we know that this pattern is going to continue. 3, 6, 3, 6, 3, 6, 3, 6, on and on and on forever. So the exact answer, the thing that tells everybody exactly what digits happen for infinity, is 0.136, but the bar goes over the 3 and the 6 because that's the chunk that repeats. Now, nobody needs infinitely many decimal places. So we could round this, as people might ask us. If we rounded this to the nearest tenth, you know what, hang on, I'm going to make this a little smaller so you can see both of these numbers at the same time. There. Oops, wrong page. Hang on, I'll get there. There we go, that's where we were. If we wanted to round this to the nearest tenth, right, we have a 6 in the tenths place, we look to the right, we see another 6. That causes this first 6 to turn into a 7. It's really important that you use this approximately, because we know that 7/10 is not the same as 2/3. If we wanted to round to the nearest thousandth, we would have 0.66, and then we'd have to decide what's going to go in the thousandths place. And of course, to the right of the thousandths place is another 6, so this one is a 7. Take a second, pause the recording, try 3/22, round to the nearest hundredth, round to the nearest thousandth, and then come back. All right, 3/22 rounded to the nearest hundredth. So we see a 3 in the hundredths place up here. We look to the right, see a 6, and we turn the 3 into a 4. So this is about 0.14. If we wanted to the nearest thousandth, we would have 0.13, and then we'd have to decide, should the 6 stay a 6 or should we bump it up to a 7? Look to the right, see that the number is less than 5, and the 6 will stay a 6. So these are all approximations. The last thing that we want to do before we flip the page is check all of this out on your calculator. So let's try 2 divided by 3. We don't even need to use that fraction converter key. We'll just enter the fraction the way we know it should be. Press enter, and there we are. So now you should understand that there is not a 7 in this. This is not an exact answer. It doesn't mean 2/3. This is what the calculator did after the 6's kept on going forever and ever, and it has limited display space. So never trust this last digit of any answer, because it could come from something that was rounded. If we tried 3/22, we would see the same thing. We can see this nice repeating pattern, and the 6 didn't get rounded anywhere because there's a 3 to the right of it. If the calculator had decided to stop and only show you up to that 3, this 3 really would have been displayed as a 4 because they're rounding over here. So you have to watch out and never really accept your calculator as being exact, especially when it comes to decimals. All right, one more. Let's flip the page. Exact versions of decimals are really cool, especially when they start to repeat. I kind of think that they're sort of fun, but we don't often need them. Or I shouldn't say we don't always need them. Depending upon what the application is, most of the time we really only need a certain amount of accuracy, which means we just need a few decimal places. So let's try this one more time. We have 8/17. We would like a decimal version of this rounded to the nearest thousandth. Yes, your calculator can do this. You can say 8 divided by 17. You can find the decimal version and round to the nearest thousandth. But, you know, let's have a little fun with this and practice our long division skills while we're at it. So let's begin. The first thing is to make sure we're dividing the proper way, asking ourselves how many times 17 goes into 8. Get that decimal point where it belongs in the answer. All right, so the question here is, how far do we need to go? Should I just keep on dividing until I eventually get no remainder, or until I find the chunk of digits that starts to repeat? And the answer to that question is no, because we wanted the nearest thousandth. In order to round to the nearest thousandth, we have to look to one place to the right. So we're going to go ahead and carry out this division. One more place. Than is actually stated, which means we're going to stop after 4 decimal places. Actually, I shouldn't say we. What I really mean is you. Pause the recording one more time, carry out the division until you have 4 decimal places, and then start the recording again. Okay, here you go. Compare my work to yours. You'll notice that I have a remainder down here of 15, which means I should keep going with this division, but I don't have to because they asked us to round to the nearest thousandth. So I need to round to the underlined decimal place, and to do that I'm going to look at the highlighted decimal place. So if we had 0.4705 stuff, that would be about 0.471, and there's the thousandths place, and so we stop. So the answer here is that 8/17 is approximately 0.471, 471 thousandths. And that's it. All right, we'll be talking to you next lesson. Have a really great day.